Good morning, superhumans. Is it too early to be this loud, or is it too late? I'll let you decide. In the meantime, I acknowledge the traditional owners of this land. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Now, I've got lots and lots of things I want to cover, so I'm going to have to try to keep it on track a little. I have a bunch of questions from Patreon and GitHub sponsors, supporters, and some of them are directly related to the things I want to talk about today. Some of them aren't, so we will see if we get through them all. And what I'm going to do today is show you a project that Chris and I have been working on for quite a long time now. And okay, where to begin? I've got a bunch of stuff. So, firstly, also, what I'm going to be talking about, this particular project, it is related to assistive technology. So, technology which is specifically designed for use by people with disabilities. And at first glance, you might think, that's not relevant to me, and what's it got to do with home automation, and why are we talking about this? Well, there are a bunch of reasons we're talking about it, but I just want to point out that even if you don't think this is directly relevant to you, or not relevant to you now, there are lots of techniques that go into this that can be extremely useful in whatever project you work on. What I'm going to be talking about is custom input devices and how you can interact with the computer in a way that isn't traditional. So not the standard keyboard and mouse sort of arrangement, or with a game, like an Xbox or a PlayStation or whatever, some kind of a game console, instead of using the standard game controller that everybody's familiar with, using some other form of input device. Now, what is really interesting about this, or what makes it really useful beyond these sorts of projects, like for assistive technology projects, is that you can use these techniques to do all sorts of interesting things with computers and link computers to external devices. And this really ties into, OBS audio is definitely out of sync. Rulesh pointed that out. I'm not sure what's going on with that. I wonder if it's got any better. My computer has been struggling a little bit this morning, but hopefully it will kind of balance itself out and sync up. Okay, so, I think I can see it myself looking at the preview here. That's weird. Okay, if you don't look at my mouth, then maybe it won't seem like the audio is out of sync. It'll be less confusing. So, yeah, it's like 1 second out. That is strange. Put a mask on. Yeah, where is the mask? I've got some in the drawer here. No, I don't think we need to wear a mask during a live stream. I'm interested. Okay, I'm going to hit stop streaming in OBS and then start it again. Thanks, Rulesh. I will try to do something about this though. I'm going to stop streaming and then start streaming again. In fact, I'm going to quit OBS and leave the stream open. Everything's going to go black for a second, but it should come back, I hope. Are we here? Are we back? The suspense. Okay, it looks like I'm back, still out of sync. I don't know what that is. And use an HDMI video capture device. Yes, that's what I'm doing. Alright. Made it worse. Don't tell me that, Scott. What is going on here? Why is it always so hard to get this stuff working? I wonder if the problem is not so much with... I'm going to try something different. Let's switch to the front internal camera. Now that looks really dark. 1, 2, open, close. That looks more in sync. I think the problem might be with the external camera. Oh, right. Yeah, the camera quality is rubbish, but I think it's more in sync. So I think the problem is actually with the HDMI capture coming off the external camera. Well, sorry folks for all the messing around, and hopefully this will all get better. I've just turned off the camera, turned it back on again, switch back to the front camera. It's now out of focus, and the sync is way off still. Okay, internal, switching back to the internal camera. Aren't computers fun? They're always so reliable. They do exactly what you want. Let's try again. Nope. Cam link. Cam link. Come on. Cam link. Nope. Cam link is not working. Oh, maybe now it will. Now it is. Well, yes. I think we fixed the audio sync problems. Awesome. So the problem was, yeah, that seems a lot less laggy now. Okay. Let's get back. Now we resume to your usual programming. All right. What a waste of the first 9 minutes. All right, so as I was saying, what the techniques I'm going to talk about today really help you to do is link external devices into a computer in a way that you may not normally be able to do it. When you're doing automation projects, there are lots of ways that can be useful to get some kind of non-standard input into the computer, or trigger actions, make it do things that are not, trigger things in a way that is not you typing on a keyboard or clicking on something with a mouse. And one of the really common ways to do that is using HID emulation. So USB HID is, the USB HID standard is human interface devices. It's the way things like a mouse or a keyboard plug into USB and then appear as a device to the operating system so that it can then take events from it. And the HID standard defines a number of different classes of device, and they send different types of information. Like if you have a keyboard that you want to type on, then you want to send key presses. And of course you want to be able to do not just simple things like press a key on your keyboard and have it send the letter A. You need to be able to do things like detect the key has been pressed and it hasn't been released yet. So you can do in software auto repeat, and you can use the information about whether the key is currently pressed, not just whether it was pressed. So there are separate events for like a key down event and then a key up event. So you can put key down on shift, and then without releasing it you can press another key and then release it and then release shift, and you get the shifted version of the second key. So there are all sorts of complications to it. And with things like mice, it's not just a simple input. It's you need to change coordinates, like move in the X and Y axes, and there are other axes, and then left and right mouse buttons and chording buttons. Lots of complications. But it's actually really easy to get started with this sort of thing. So what I'm going to do is show you a device that implements it. In fact, before we get to that, let's look at this, which is the Xbox Adaptive Controller. And this came out, it was a year and a half, must be 2 years ago, somewhere in that region, give or take. And I'm really impressed by this. Microsoft has done an amazing job. So what the purpose of this is for people who want to play computer games or play games on a Microsoft Xbox, and for whatever reason they can't physically use or have difficulty using a traditional game controller. So it could be someone who has, it could be something like missing fingers, or it could be muscular dystrophy resulting in lack of strength and mobility, or it could be a result of having tremors. There could be some kind of a nerve-related problem that causes someone's hand to shake, which makes it hard to use a traditional controller, or it could be partial paralysis. I mean, the thing is that there are so many different reasons that people might need some kind of a non-standard input to a computer, and there is no one size fits all. That's actually what makes this really interesting and challenging, is you have to be able to build devices that suit the individual. You're not building devices that suit the common baseline. You're trying to help a specific person do a specific thing. And so what Microsoft did, in conjunction with a group, I think they did this with Able Gamers, I can't remember. There is a group specifically for helping people with physical disabilities to be able to play computer games. So Microsoft put a huge amount of thought and work into this, and you can see it right from the box. In fact, that's why I'm showing it to you in the box now instead of just showing you the device. So what they've thought about are things like, if someone receives this, it's been given to them or sent to them, like shipped to them, and they receive it and they need to use it. If you have some kind of a physical disability, you might have like a lack of coordination or something, some reason that makes it difficult to use a regular game controller. That's been considered in the packaging. So it's got this pull tab on here. So if you grab the pull tab and lift it, it opens the box and it exposes the controller. Now I'm holding it on an angle here, so it's all going to kind of fall apart. But then there is this handle that makes it really easy to get out. So you can grab the handle and pull it, and because I'm holding it up in the air, it's all going to fall all over the place. But it lifts the controller out of the packaging just by grabbing this large handle. So they've given a lot of consideration to the packaging as well. So getting it open is really easy. And then once you've got it out, I just saw Scott's comment about the shirt. Yeah, that's a G, not a C. Grapple Hearts. So this is the controller, and as you can see, it's got some features of a regular game controller. There is the little directional pad on the side here, except that it's larger than normal. It's got a couple of buttons on here. It's got the PlayStation, the Xbox button, which is on a standard controller, and then it's got large inputs, which I think are A and B. Yeah, they are, so A and B. And the idea is that you can plug this into a game console, and it appears to the console to be a standard game controller. So then by pressing on this, you can press A. With this you can press B, and there is a large input here. So what you can do is, with this just plugged in, no other changes, you can interact with the game console, you can go through menus, you can select options, you can change accessibility options and things. And these pads are large, so that for people who have issues like tremors or coordination problems, it's easy to hit this. You don't need to be super accurate like with a little button on a game controller. But where this gets really interesting is when you spin it around, you see this row of sockets along the back. There are 19 sockets on there. They are a standard 3.5mm connection, same as on a typical headphone. And each one of these corresponds with one of the 19 inputs that are on a standard game controller. So what you can do is plug this into your game console, and then plug custom input devices into these little sockets. And then when you short circuit the connection on that input, this adaptive controller sends that action to the console. Alright, so just as an example, simplest example possible, this is just a regular 3.5mm headphone connector on a cable with a button on the end. And all it does is when you press the button, it shorts between the tip and the ring. So if I wanted to send, let's see, R, LT, alright, say I wanted to send, doesn't matter which one I'm picking, send the X button event, what I could do is plug this in here, plug this into the game console, and whenever this is pressed, this will send the X button event as if you were using a standard game controller. So what this provides is a gateway out to, it's a big breakout really. It's almost the same thing as if you got a regular game controller, took the cover off it, and then you soldered wires across the back of all the switches so that you could activate them externally. But this just does it in a really neat way. And just to continue with the theme of the industrial design and how neatly they've thought about this, these little sockets, they're 3.5mm sockets. If you have an issue with dexterity, it can be hard getting the connector into here. So what they've done is on the case, it's going to be very hard to see on this, but if I get this up in front of the camera, on the case there is a little groove running down to the socket. So as a test, so I've got this facing away from me now, I can't see it at all. If I grab this, so I can put that into the socket without even looking at it. I'm not looking at the camera on the screen or anything. All you have to do is feel the end and the little groove in, I'm sliding it up and down there in the groove. There's a groove in the case, it guides it straight into the hole. So you've probably had so many times that you've had to plug in a socket and you try to get it into the hole and you're sliding it around and you can't find it. With this, that tiny little affordance makes it so easy to get the plug in, and it's a nice little feature that they've designed into the case. Anyway, right now this sounds like a big infomercial for the Xbox Adaptive Controller, and I've got to say that I am very impressed that Microsoft did this. If you look at what it takes to manufacture a device like this, and and all the commercial considerations, they could have made this a $500 device, without any trouble at all. They could have just put a $500 price tag on it and been done with it. But they sell it for $90, so I don't even know if they're making any money on these. They may not be. But I wanted to show you that because it's an example of a commercial product that does very similar things to what people in the disabled gaming community have been doing for a very long time, and what you can do using things like an Arduino Leonardo or many other types of boards that can do human interface device emulation. So the project I'm going to show you today is the Mini Open Adaptive Controller. Now, Chris and his brother Nick have been doing this for a very long time, like 10 or 12 years, using Leonardos. In fact, I'm going to switch over. Okay. I'm going to switch over to the desktop, and this is a photo of Chris using his computer, and what you can see on his left hand is that his arm is resting on a block of foam with his hand falling into a natural position. So the arm is supported, hand just falls into a relaxed position, and the fingers are sitting on this little blue thing here, which they call a button box. Inside this box are some micro switches, and the 3D printed structure has these long arms on it, or fingers, that provide mechanical advantage, so that it takes very little force to activate one of these switches. And you can see that there are 4 here to correspond with 4 fingers, and what you can't see because it's blocked by Chris's hand is his thumb on the other side is also against a micro switch. So he has finger control and thumb control. And the cable for that is this little cable that comes down out of the bottom of it, and that is actually going to an Arduino Leonardo, which is plugged into his computer. And when he wants to send certain keystrokes to the computer, he can use a finger to activate one of the buttons, and the event is sent to the computer. And then he can do things like, so on his right hand that you can see up here, there is a gaming mouse which is set to the maximum possible resolution and acceleration. So it requires only a few millimeters of movement to move the cursor across the entire screen. So with the combination of the gaming mouse and then custom keyboard events coming in from his left hand, Chris can use quite a wide variety of software, and it's particularly well suited to Fusion 360. Oh, Bonnie's getting excited out in the yard, chasing something. So yeah, and Chris and Nick have been using this for more than 10 years, I think about 12 years now. So this is a project that we've been working on for a little while, and well, you can see it's up to version 2.1, and okay, so from a functional point of view, you can think of this board as really being an Arduino Leonardo with inputs just wired to sockets, and a couple of other features that aren't really all that important, but that help a little bit. And I've got one right here. I'll show you the real thing in a moment, but let's start by looking at the design. In fact, we'll go to the schematic. So down in the bottom right corner here, we have an ATmega32U4, which is the same processor as used on the Arduino Leonardo, and it's just got its standard supporting parts off on the left here, the crystal, etc. There's a USB interface. None of that is particularly interesting. Over on the right, we've got some inputs here, so connected through buttons 1 through 8. We've got 1 through 6 at the top, and then buttons 7 and 8 down here. And then we've got a piezo buzzer for sound output, and there's a switch for it. Some LEDs just for RX and TX. There is a header here for an OLED. There's a 1.3 inch OLED on it for giving some visual feedback. And then these inputs, so here we've got A0, so analog input 0 is pulled high through a 10K resistor, and then it's got a 1K isolation resistor going to the socket. So here we have a socket, and effectively what happens is that this input is held high through the 10K resistor unless you short circuit this socket. So if we take a button on the end of a wire with a plug on it, you plug it into that socket and press the button, it pulls this input low. So what we can do is, by detecting this input going low, we can then do something in the firmware. And the board itself looks like this. And so it's a kind of long and skinny board, and the reason for that is just because of the sockets. They're all laid out along the bottom here. There are 8 inputs. Each one of these, it's actually I think it's a stereo socket, but I'm using it in a mono configuration. You can see the processor. So there's the CPU. Over on the left we've got the USB-C connector. Over on the right there's a piezo, and up here we have the headers for the OLED. So there's a display that sits on the top of it. So what this looks like, in fact, let's flip through to here. So this is the board in Fusion 360. You can see the sockets running along the bottom and the processor. There's the USB-C connector on the end, and you can see that there is the OLED that sits up. It sort of sits on top of the sockets. The position is not quite right here in this model. The OLED actually sits up slightly higher than this. It's just my model is not 100% accurate. And then we've got a 3D printed case. So there's the bottom part of the case that it sits in with some screw holes that go through the PCB, and the top part of the case that goes over it and encloses it. So it just exposes the display on the top, sockets, and the USB-C on the end there. And then over on the back there is a switch. So this switch is to allow you to physically override the beeper internally, so you can disable the beeper. And so you can disable it either in software or hardware. But the idea is that it should be possible to do it in hardware so that you don't have to change compile options and upload new firmware just to turn the beeper off. So the device itself is here, and you can see a little glow. That's the power LED glowing through the 3D printed case. So we've got sockets on the bottom where we can plug in inputs, and it's currently plugged into my computer for power. Now if I go back to, let's see what I can go to. No, I'm going to go to the Arduino IDE for a moment and switch back to desktop. Alright, so this is the firmware that goes into it, and just going to make some space here. So we've got a couple of blank lines, and I'm going to take a button input, button, plug it into the last socket, so socket 8, and if I press this button, it sends a keyboard event. You can see flashing up on the screen here, the letter appears briefly, and each time I click it, the computer thinks that I have a keyboard plugged in and that I'm sending it the number 9. I'll plug it into a different socket, and now I'm sending a 7. And you can also hear the the piezo that is buzzing. So this is an interesting starting point, because what this allows us to do, just with this as a building block, is act as a bridge between the computer and being able to send any kind of input event that we want. This could be, at the moment what I'm doing is sending keystroke events, but it could be sending mouse events. So what we could be doing, for example, for people who can't physically use a mouse, we could have buttons set up so that when you press the button, like one button might move the mouse right by 10 pixels and another button moves it left, etc. So with a series of buttons, you could then move the cursor around the screen and interact with software that requires mouse input just by using buttons. So that gives you a huge amount of flexibility. And the thing is that this sort of thing is cool for as an assistive technology project, but it has applications way beyond that. For example, what if you wanted to do something like be able to trigger taking a screenshot using a foot switch? So with this device, anything that it can short these inputs can send an input of, an event to the computer. This is the simplest possible case, and this is what I use for testing just because it's easy. I can plug it in and press the button. But you can do things like use a foot switch. So this is a cheap and commonly available foot switch, just wired up to a cable with a plug on it. And by activating the foot switch, we can do the same thing. So, let's try something a bit different. I can't remember what events I've got tied to the different inputs, but if I activate this now, let's see what happens. Okay, so it sent some characters, and that is because I have my keyboard currently set in Dvorak mode. I'll set it back to Australian mode. Now, what was that word? Oh, hello. Okay, so it's with one press event, it has sent not just one character, but it's actually sent a string of characters, including a space at the end. So I'll move it along to the next input. send that one. In that case, it said there and then a new line character. So you can see that it's not just one input that sends a single character. It could be sending anything. It's arbitrary. You can define exactly how you want this to behave and what things the computer should be seeing. And now the thing is that there is no customization on my computer at all for this. It doesn't have any idea that the thing that we've got plugged in is this. It thinks it's just got a keyboard plugged in. So it means that you can build custom input devices that will interact with a computer in a totally unmodified state. You don't need to run specialty software in order to use this or have some special kind of drivers. To the computer, it's just keyboard or mouse or joystick or game controller or whatever. So in the code, what we can do is emulate different things. Now here I've got, now in this particular example firmware, I'll go back over to config just to show you what's going on here. What I've got here is a list of the things that are going to be sent when the different inputs are activated. So here you can see, just because I've got 8 inputs, I've got 5, 6, 7, 8 as a single number that is sent when you input. When you trigger input 5, it'll send a number 5, etc. Now, a moment ago when I was sending input 8, it was actually sending the number 9, and that's because I'd modified the firmware since then. So in these cases you can see that it's just a simple character, so the number 5, or here it's sending the letter A, and here it's B with a new line, or the word hello with a space, or there with a new line after it. So by customizing this, we can do whatever we like. Let's see, I've got to remember how to type on a QWERTY keyboard. Let's try this. Let's put a new line on the end of it, and I'll try flushing that. So what is this? This is input number 5. So I'll plug my button back into input number 5, and hopefully, if I've selected the correct device in the IDE, which I may not have because I've got a few devices plugged into my computer right now, this will be uploading to the correct thing. Looks like it is. Yeah, so it's just powered up, it's given its hello message. So now if I make myself a space in the code over here, and then I activate this, it says, hello there superhumans. So we can send like arbitrary inputs to the computer just by pressing a single button. Or this could be a motion detector, or it could be a foot switch, or it could be a chin switch, could be a sip and puff interface, could be like a head switch. So many possibilities. Once you start thinking about things as being buttons, it opens up lots of ideas. So, I'll just pop this open and show you what's going on inside here in the real thing. Now this is actually a previous version of the hardware. This is hardware version 2.0, and we're now at version 2.1. The only difference really is the hardware control of the piezo. On this particular one, there is no switch up here to turn the piezo on and off. So the only way to control the piezo on this particular model is by turning it off in the firmware. But we now have this one. So this is the version 2.1 hardware, which has this switch on the top. Now this switch is tiny and it's hard to activate, and it is definitely not ideal. And I suppose it's a design compromise I wanted some way of being able to physically disable the piezo without having to recompile the software. So this kind of gets into some interesting questions about about how to make these as accessible as possible, and how to put power into people's hands to be able to change them and reconfigure them to suit themselves. And a lot of that can come down to whether the individual has someone with them to be able to do things for them, like change settings and configurations, their level of technical knowledge. There are so many variations here as to whether this sort of thing will solve someone's problems. And so I don't know quite where I'm going with this. I suppose what I'm trying to say is that this is an engineering compromise, and all engineering is compromises. I mean, the best case scenario would be for things like this control over the audio output to be easy to change by people who don't necessarily have the strength or dexterity or whatever to be able to flick a little switch. But putting a switch on here which does allow that is still not necessarily going to solve the problem for everybody. There is no universal solution here. It's basically this was the best I could come up with, and I figured that for people who have a carer who helps them with physically setting things up, then this should not be too much of a problem. For people that don't have a carer, then this could be a problem. And this gets into some of the questions. So there were some questions in the oops, I've got to switch my keyboard back again because I can't type on a Dvorak keyboard, not without a lot of difficulty anyway. There were some questions from Patreon supporters and GitHub supporters. Where are we? Live stream questions. Here we go. So, okay. James O said, it would be interesting to hear about the differences in developing assistive tech versus other things. I was considering offering feedback and whatnot about the Joystick, but not sure I'm really qualified. Now, that is a really, really important point. And it comes down to something that I've learned or had reinforced multiple times over the last few years. So in the time that I've been working with Nick and Chris, the fundamental lesson here is that we all approach the world, or we see the world from our own perspective, and our expectations are set by our own previous experiences. What we think is the solution to a problem is the solution that we can conceptualize or that is important to us from the way we are looking at it. And it's really important to be able to get past that. That's something that very early on when I started working with Nick was to be very conscious when I was trying to push a solution to something that Nick did not necessarily want or agree with or need. And my expectations of what would be useful to him were not necessarily accurate. And the critical thing was to listen and to not try to solve the wrong problem. So, as an example, all right, I'll try to come up with an example for this. My expectation when I started working with Nick was that what would be useful to him is the ability to control physical devices in his environment in a home automation sort of context. Things like controlling lights, controlling blinds, opening and closing a blind, and turning on and off heating, and those sorts of things. Now, the thing is that I'm being a little bit careful here because I don't want to overstep boundaries, and I don't want to be speaking on behalf of someone else. But what I saw working with Nick and Chris is that my expectation of their needs and what would help them with what they wanted to do was not the same as the way they saw it. And because in their situation they have a carer with them 24 hours a day, so they are never alone and having to do things in their physical environment without assistance, it means that certain things that automation could help with aren't even relevant. A classic example is curtains and blinds. So in a home automation system, like in my house, every single blind in the house is automated. Actually, that's a lie. There's one that's not. There is a very small one near the front door that is not automated, and that's because it's so small that you can't fit a motor inside the tube, and we could do it externally, but that's another story. I'd be chasing a squirrel if I got into that. So my expectation was that doing things like setting up automated blinds and curtains would be helpful for Nick, because he would be able to control it from his wheelchair using an interface like OpenHab on his phone linked to the wheelchair controls. So the wheelchair can make a Bluetooth link to the phone, which means that the wheelchair joystick can be used to move the cursor and turn things on and off in the OpenHab interface. And so I went in there thinking, well, what we could do is we could set up automatic blinds, and we could link the lights to OpenHab, and we could do these different home automation things. And that would be beneficial because then Nick could control them directly himself rather than relying on someone else to do it for him. But the thing is that because Nick and Chris have a carer with them 24 hours a day, that level of automation is irrelevant because there is always someone to do it. And it's effectively they have voice control of their environment, because Chris can say, please open the blinds, and his carer will open the blinds. So that need is not there in their specific situation. So I had to very quickly recalibrate my own thinking and not be saying, Nick, I think this is what you need. I could come up with lots of suggestions because there might be things that Nick hadn't thought about. But if he wasn't interested for whatever reason, it's not my place to then say, no, you really need this. It will make things better. The important thing is to respect the person that you're working with, and to solve the problems that they want solved, not the ones that you want to solve. And so that was a couple of years ago that I was working with Nick, and working with Chris now. So if we look at that scenario, so control over the physical environment, one thing that Chris uses all the time is OpenHab to control the heater under his computer desk so that he can keep himself warm. And that is a classic home automation system. It is OpenHab with the app running on Chris's phone, and then there is a Sawn-Off which is plugged into a PowerPoint, and then the heater is plugged into the Sawn-Off, and he can use it to turn the heater on and off. It's fantastic. And that is something that Chris uses every day. And it is a good example of using home automation it is just straight up home automation technology. There's nothing unusual about it. It's not something that you would look at it and say, hey, that's assistive technology. It really is home automation, making someone's life a little bit easier. But if I remember correctly, it took quite a while before Chris decided that he wanted to do that. I remember mentioning very early on, hey, we could automate control of the heater, and Chris wasn't interested. And then a little while later, I think he'd thought about it for a while and decided, yeah, it actually would be useful to be able to control the heater myself. So we did a couple of iterations. The first version, what we did was he had a heater with an infrared remote control. So we opened up the remote control and then wired a Wemos D1 Mini into it and had it subscribed to MQTT. We might have even had it running Tasmoda. I can't remember what firmware. So that from OpenHab, what he could do is essentially send infrared signals that would turn the heater on or off. But and the reason we had to do it that way was that the heater had an electronic control system. So if you turned off the mains power and turned it back on, it would always come up in an off state. We couldn't control it just by turning the mains power on and off. We needed to send the infrared signal to it. And that worked for a little while, but then eventually the heater died. So Chris switched to using a simpler heater, which is just a little electric space heater with, you know, the big mechanical twist switches on the top, which means that if you put it into the on position and then you turn off the power point, turn it back on again, it just turns back on, which means we can control it with the Sawn-Off, and it's a much easier sort of plug-in job. Oh, right. Now, I'm going to quickly go back to the some of the questions. There were some other questions in the supporter stream. Where am I going back to? Yeah, I think that was mostly what was related to assistive technology, but there are some other questions that I'll get back to as well. Oh, Brett, yes, Daryl said, so Daryl did wonder about a camera over the fingers and detecting movement that way. AI on processors is way better these days. Yeah, so that is another way to do it. And the thing is that that might be a better solution for people in some situations, if you can get the sufficient resolution and you could do the pose estimation. So, okay, I'm going to chase a squirrel just for a second. If you have a camera pointing at a person and you want to be able to do things like gesture detection, so you want to know if my hand is open or closed, or if I'm waving, the way that is typically done is a multi-stage process, and one of the first parts of it is the software doing a thing called pose estimation, and the pose is the pose of the person. So it might be doing this, or, you know, whatever. It is the position of their limbs and their body, etc. And so what it does is figure out where their arms, etc. are, and then create a skeleton, which is essentially like a line. So in this case, there would be a line from the center of my palm to the elbow, and that line represents the position of my forearm, and then there's another line from the elbow to my shoulder. So you end up with a stick figure person that is a representation of the pose of that person. And depending on the degree that you go to, like the pose estimation could be just the position of the arm, or it could go to the extent of tracking the position of the fingers individually. And then if a person moves, the little stick figure fingers move, and then by looking at the position of the pose, so looking at the position of the stick figure representation, you can then do an analysis and decide, is the hand open, so all of the fingers are straight lines, or is it curled up so the fingers are curled? And then use the pose to as some form of input that you can then send to the computer. Well, send to some other process within the computer. So it could be used for gesture detection, like move the mouse right, move it left, move it up, move it down, and have it track your hand by following the pose and the XY position of the hand. So that sort of thing could be a solution in some situations, yes. Now, okay, so tying this back into what James said, that comment I was responding to a few minutes ago. So James said, I was considering offering feedback and whatnot about the Zero Stick, but not sure I'm really qualified. I didn't really address that part of the point. For me personally, I am totally open to feedback, because part of this is, and part of what I was talking about earlier, is admitting that I don't know what I'm doing. I can solve specific technical problems, but of course I do it approaching it from from the point of view of the way I think about problems and in the context of problems I've solved in the past. Like if I've solved a certain thing in a certain way, I will tend to solve it in the same way in the future. I won't necessarily come up with a totally alternative way of doing it, like what Daryl was saying, using a camera and then tracking hand position to detect movement instead of using switches to detect movement. So the way I think about this is I personally love hearing different ideas, and those ideas may ultimately be impractical. It might be totally ridiculous, or it might be the eureka moment that makes you think, yeah, I could solve this in a different way, and that actually makes things a whole lot easier or better or whatever. And so being open to input from people with different experiences and different expertise really helps break you out of that mental situation where you have a hammer so everything looks like a nail. And I've been trying to do that a little bit myself in a few different areas. For example, I mean, this thing is a classic example. I did this using an ATmega 32U4 MCU because I've used the 32U4 on other projects in the past. I'm familiar with it. In so many different ways. I have example code that runs on it. I've got a footprint that I can lay down on a PCB, and I've produced so many boards using that part that I know the footprint is accurate and the part will fit. And I know how to recover from problems with it. I know what all of the I/O connections are and how they behave. I'm intimately familiar with it. But that does not necessarily mean that the 32U4 is the best processor to use on this board. And so one of the things I've been doing recently is looking at alternative processors. So I've been using things like the SAMD 21. Where's that? Just wondering if there's an example. I don't think there is. In fact, I've got a... yes, there is. And the example is the Zero Stick that we were looking at last live stream. So the first version of this had an Arduino Leonardo attached to it. No, it's not in the box anymore. But this was all prototyped using an Arduino Leonardo with connections plugged into the headers. And then I ended up switching over to a Cduino Xiao, which uses, so it's a Cortex M0, and this does HID type stuff really well as well. It's got some differences in things like how the drivers work, like the library that you use for compiling the code on this is obviously different. It's a totally different processor architecture, and the way some things work on it is different, but it does the job. And it has some interesting advantages. One is, well, firstly, it's faster. Secondly, it's cheaper. So this processor is significantly cheaper to buy. And by processor, I don't mean the Xiao board. This is a complete board with the processor, its supporting parts, USB-C connection, it's all on a PCB, etc. So that's a complete little dev board. But I mean, if I'm building a board like this, and I want to put a processor on it, what processor do I choose? And I could be doing that using the same processor that is in this. And it is better in almost every metric. The only, and there are two areas where it may be slightly less better, I suppose is the way to put it. And one is that if you are giving this project to someone else to mess around with it, then you want the fewest possible hurdles for them to overcome. And for most people, saying download the Arduino IDE and change these configuration values, you can't see what I'm looking at here, download the IDE, change these configuration values, and then plug in the device and click upload, and you've got to select these things in the menu. That in itself is a significant barrier. Most people are not going to be able to achieve that without someone looking over their shoulder and helping them. It's a big jump going from not doing any electronics or software development to compiling something for a sketch and then uploading it. Now, if you have to take the added hurdle of, and you also have to install a custom board profile, which means you've got to go into the Arduino preferences and you've got to find this particular URL and paste it in here, and then you've got to go into the boards manager, and then it does its update, and then you've got to find the right board profile and install it. That is all an extra barrier that is a bit of a pain. Now, luckily, so in the past, that has been a motivation for me to stick to processors that are supported out of the box by official Arduino models. So for any project that is not like a commercial project for someone else, or where am I going? Or that is not just something for my own use. But even then, what I try to do is choose from things like processors that are already supported in the Arduino IDE out of the box without installing any custom board profiles. And that then gives you a limited selection to work from. Now, of course, there are official Arduino models that have got the SAMD21 processor on it, and that means that if I build hardware that suits that particular board profile, that's one less barrier for people to overcome. So that is one of the two slight limitations. The other slight limitation is in out-of-the-box support for certain libraries, because the timers work differently and there are other internal differences with the processor. I won't go into it too much. But basically it just means that if you're working on code for it, it means you've got a few extra hoops to jump through to try to get things working. So when I switched this over from the Leonardo to the Arduino Xiao, I had to compile it with different libraries and make some changes, so it was not quite as straightforward as just change the target board and click compile. There are changes in the code as well. It's a funny story from Daryl in the private chat. So he says, when I was doing my degree, the engineering school had a story about a company that was asked to install a new lift, as the two current lifts always had a queue and people were annoyed waiting. This was going to cost hundreds of thousands of dollars. The engineer said, I can fix this with $10, and everyone went, really? So they said, do it. He installed some mirrors in the lobby, and so people looked at themselves while waiting and all the complaints went away. Lateral thinking. Alrighty. So, now I've just got to catch up on some things. So, in relation to some feedback, some comments that have come up while I've been just talking and talking and talking. All right, so Rulish is always watching these live streams. Thanks, Rulish, and always there with suggestions. Said, haven't looked at the brain-computer interface space for a while. I wonder if they've made any tangible progress. And okay, that is a very interesting topic. In fact, I have a video. Let's see what I can find. I may have a video here. So there are a few different approaches to this. And it's one of those things that comes up where when you look at interface options for people with severe physical disabilities, like someone who is quadriplegic or has advanced muscular dystrophy, being able to interface directly with the brain seems like that's going to solve the problem. Sorry, while I'm talking here, I'm also scrolling through a list of images and videos and things, trying to find an example. I don't think I have it here in this folder, and I'd be wasting your time if I went looking for it. So about a year and a half ago, Chris went to a centre in Melbourne and was fitted up with a device called a neuronode. And a neuronode, it's an inductive sensor, so it detects electrical activity in muscles, not necessarily directly within the nervous system, because those signals are so small that you can't really detect them externally. You need to insert some kind of a probe or an electrode into the nerve. What the neuronode does is have a sensor that is attached on the outside of your skin, and it detects electrical activity within the muscle. Now, and this is really where it comes down, it very much comes down to the particular characteristics of the disability that you're working with. So in the case of muscular dystrophy, there is a lack of, I'm not all that clear on the science of it, but the end result is that there is a lack of firing of the muscle. So the muscle fibers do not get the electrical signal that they need in order to activate. So it results in muscle weakening over time. And so if Chris wants to clench his fist, for example, to clench the fist, the muscles to do that are down in here. And if he applies all his strength to clench his hand, by picking up electrical activity down in this area, you can possibly detect when he is doing this. And it kind of worked, but the threshold was fairly low in terms of the amount of electrical activity it was picking up, and it was there were a few things. Firstly, it was incredibly expensive. I can't remember the number, but I think it was, I might be wrong here, but I think it was something like $15,000 for the device for one channel. I have a feeling that the device could be expanded to multiple channels, but like the base device to pick up one channel, which means detecting one muscle activity, was $15,000, and it also took a fair bit of fiddling to get it into the right position. So attaching it and doing the setup is not easy. It's not just a matter of oh, I've put a strap on and now all of a sudden I can detect muscle activity. It was the technician very carefully moving electrodes around and trying different positions and watching the machine to try to get the highest signal possible out of it. And going through that process is quite a burden. If you had to do that every day or multiple times per day with multiple electrodes, so for many people, that technology, like the neuronode technology, is amazing. It's changed their lives, but for other people, it doesn't necessarily apply. It doesn't solve the problem for various reasons. And so in Chris's case, he decided not to really pursue it and look into it more. But then there are other things. So I think what Rulesh is talking about is the skull cap type systems. You've probably seen in science fiction movies, if nowhere else, someone has a thing that's like a headband with electrodes and fingers over it, and you put it down on your head and it makes contact in different positions and it detects brain activity, and the idea is you think very hard about a specific thing and the computer can detect it. And those systems can work, but at the moment they're still fairly crude. And I've seen videos of some interesting experiments. There are things like thought-controlled wheelchairs, which are really cool, but the response rate is very low. And when interacting with some kind of computer system or a game system, we're used to interacting with it in a very low latency way. So if you move a joystick, you expect that there is going to be a response immediately. And with things like the current technology of brain interfaces, they kind of detect trends over time. So you might think about something, like concentrate and think about a specific thing, and the computer will take a few seconds and work out, okay, you are thinking more and more about that. So if you're doing a demo, like on a computer screen, you've got a cube and you want to control the cube by thought. So you think very hard in a certain way and you can make the cube move up or you can make the cube move to the right. That is a super impressive demo. But in terms of controlling things in the physical environment, it has some real limitations. If you're using that to control a wheelchair and you start thinking, okay, move, 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 the chair starts to respond and begins to move, and then you want it to stop, there is so much latency that by the time you've got the chair to stop, you might have totally overshot where you're trying to go to. So it's incredibly interesting technology, but it's still in the early, I say early, it's been going on for a long time. It is not where science fiction would make us think that it is. It's much cruder than that at this point. But it is very cool, and I would really like to play with that. I've never actually played with a brain interface, and I would love to. There was a comment from Nautronic saying, capacitive switch where you hover your hand for several seconds, and Scott said capacitive touch fails if you have tremors. Yeah, so there are a couple of projects related to that. So this is a project that I've shown on Twitter and different places. And I've talked. When Chris and I did a talk at LCA in January, we mentioned this in passing. This is a capacitive touch switch controller. So I designed this to go on a wheelchair and take its power from the chair instead of using a battery like touch switches on wheelchairs currently. And that's the touch switch pad. This one is my version. So this silver part that you can see is actually a PCB. So I designed some little circular PCBs. It's sitting in a 3D printed base, and you can't really see it very clearly, but in the back, that's where the wire connects to it. So the back of the PCB has solder pads for the wire, and the wire then goes, well, at the moment it's just going to a header, but that goes to, where did I have it? To the touch switch controller. So the idea is that this is mounted on a wheelchair in a position where Chris's hand can just come down and touch it and activate it. So the output from this could, for example, go into the adaptive controller and send events to the computer. And here is a commercial version of the same thing. So this is a touch switch controller made by a company called Permobil, which make wheelchairs, one of the two big wheelchair manufacturers in the world. So this one's not ours. This is the Permobil touch switch interface with their controller, and it's got a battery in it, and the coin cell battery that goes flat every couple of months, so it's got to be replaced. And then it's got an output, which is the common switched output. In fact, I could, let's do this just for the fun of it. I'm going to take this, which is currently still plugged in, and I'm going to take this. Now, which input did I have? Input 5 was the one that I had that message on. So I'm just going to plug the touch switch controller into the Open Adaptive Controller. So this is the Permobil one. Got the touch switch here. And then I'm going to switch back to the desktop so that we can see what's coming through. Let's delete this. I'm going to switch back to Australian keyboard mode, and because this touch switch is brand new, it's never been used, it's still got its plastic tape in there, I'll pull that out. So the touch switch has now calibrated itself, and you can see that it sent a bunch of outputs while it was calibrating. But now if I touch this, we're getting input to the computer from the touch interface through the Open Adaptive Controller. So that's actually the first time I've tried that, and that is I mean, how long did that take? 2 minutes. Pulled it out of the box and plugged it in, and it worked. I've never actually had those two devices connected together before, but that is a good example of the universal nature of these inputs, and the way a 3.5mm jack is used as a standard interconnection between assistive technology devices. Oh, and Dodgy Brothers said, is that a touch plate for the CNC? No, it could be though. It could be used as a terminal for that. It looks very similar. I've got a touch plate for my CNC machine, which it looks the same. It's just physically a bit bigger. It's a structure of a very well, accurately known thickness with a metal surface on the top. So you can put it onto the bed of your CNC machine, move the tip of the tool down and until it touches, and you can detect the touch electrically because you have a connection to the tool. On the CNC machine, you have a connection to the metal plate. It moves the tip down, and as soon as it touches, it gets a short circuit through the tool, and then that's the 0 point for your machine. Well, it's an offset for the 0 point. Anyway, I'm chasing squirrels. Let's not do that. So a couple of other comments. Yeah, so Scott said capacitive touch fails if you have tremors. It can, yeah. And Chris suggested beam break switches. Yeah, that's another option for it. So if you can physically move, so if you've got a range of motion that allows you to move in and out of something like a light beam, then that's an option as well. One of the issues with Duchenne muscular dystrophy in particular is that it causes weakening of the muscles, but it also causes a decrease in the range of motion. So it's not just that it's hard to apply force, it's also that it is no longer possible to move muscles through a full range of motion even without resistance. So with no resistance, and with Chris's hand supported, no resistance in a natural position, he has a very small range of motion at his fingertips. And so it's a matter of, yeah, this really highlights that there are many different ways of approaching this, and different characteristics that you might want to measure. You might want to measure deflection, or you might want to measure force. And those two are totally different things. So, okay. Oh, Dodgy made another a suggestion about the zero deflection joystick. So Dodgy said, got speaking with a friend after the last live stream, you can dramatically improve that zero movement feedback joystick by putting them on the same axis instead of having them separate. Okay. I think I need more information about that. I don't quite follow what that suggestion is. Is that putting both of the load cells oriented the same way? Because at the moment, our limitation with the load cells, so what Dodgy is talking about there is the zero stick, which I showed at the end of the live stream last week. In fact, I wonder if I can show that now. I didn't show it working last week. I'm going to unplug the adaptive controller and we'll see if everything goes insane. Where is my cursor at the moment? Oh, it was up on one of the other screens. Alright, so I'll plug in the open adaptive controller. Is it going to work? Yes, it is. Alright, I will switch back to desktop so you can see what's going on. Oh, but before I do, I'll just do a quick refresher for people that haven't seen this. This is a joystick that doesn't move, so it's called a zero deflection joystick. It's mounted in this piece of wood just because this is convenient for me when I'm testing. I have this just sitting on my bench, but ultimately this would be mounted on a wheelchair frame using the metal mounting bracket that's down the bottom there. And so the control is done from the top of the joystick here, but instead of having switches or detecting deflection of the joystick, it has load cells. So there is a load cell that you can see here. It's the same sort of thing as you would find at sort of kitchen scales. And there's one load cell for the x-axis and one for the y-axis. So they're set at 90 degrees apart. This little circuit board on the side is a board I designed that's got dual amplifiers on it. No, not amplifiers. They're 24-bit analog to digital converters. So these are running as a Wheatstone bridge sort of arrangement going into the ADCs, and then that's being read. So we can measure the force that's applied in x and y axes. And if I switch back to the desktop and move the cursor over here, so what I'll do is move this up here, and this is going to be quite tricky actually because the acceleration is set very high. Which angle shall I do this so that you can see it? Now I can move the cursor right, move it left, now moving it up and down. Now it's a little bit hard to see from the little picture-in-picture, but I'm not actually moving this joystick. All I'm doing is applying force in different directions, and I can move that cursor around. And I've got some buttons mapped on it. So I've got left and right mouse button, so I can do right mouse button and then move down. Well, let's do auto format. So right mouse button, move to auto format, and click the left mouse button. So I've got full cursor control of the computer using this zero stick. So at the moment, so our problem with this is not sensitivity. It's we've got more sensitivity than we need. I'm currently using 300 gram rated load cells. So they are rated to a maximum of 300 grams full scale, and beyond that you can damage them. And so just barely touching this, I can, yeah, we can detect it very easily. So the problem is not responsiveness or sensitivity. We have plenty of that through this joystick. But anyway, I would like to know more about Dodgy's suggestion on that. Alright. I have a couple of general questions here in the chat, which I will get back to in just a moment, in relation to Sawn-Offs and certification and other things. I won't forget about those. But I just wanted to wrap up a couple of things, and this gets on to a really, really interesting thing that I wanted to talk about. There are some comments here from Scott Miller and Chris and Daryl who are talking about the whole issue with configuration. And Scott said, if you're going to hand a device to someone else to work on, build in a way to update parameters without messing with IDEs. And Chris suggested just upgrade to SAMD51 for future expansion. Yep, so other processors could be good. And Daryl said, for the configuration, could you put an ESP8266 onto the board, then have a web server that allows a user to config and save EEPROM? Your 18 mega can read config by asking the ESP8266. Cool. So all of these comments are directly related to something that I was wanting to talk about, not in great detail, but we'll just cover it now, which is how do you configure something like this? And there is quite a community built up around building custom keyboards. And there is example firmware and there is a keyboard configurator. Now, off the top of my head, sorry, I can't remember what it's called. But there are many people who like to build custom clacky keyboards using cherry switches, and so they're really obsessive about using the particular type of switch with the right activation force and the right level of clickiness and bounce and all of those characteristics, and with the keys exactly where they want them to be. So there are many people who build custom keyboards by making a custom PCB that lays out the keys exactly where they want them. And because so many people have done it, there's kind of not, I was going to say standardization, but it's more like a convention. There are a number of firmware projects in relation to the firmware that runs on custom keyboards and the configuration system for them. So one of the things that I've thought about doing is trying to make something like the Mini Open Adaptive Controller compatible with existing open source custom keyboard firmware that come with configurators. So there is a GUI that you can run on your computer, and you can do things like change key mapping and what events you want to be sent when certain keys are activated. So that stuff exists. Now, the idea of putting in an ESP8266 as well and having some kind of a web interface for configuration, yep, that's an interesting idea as well. So one way to do this is for the I'll end up chasing this squirrel way too far. I've got to try to not go down that track too much. One thing that Chris and I have been talking about is doing something like writing an Electron app, which essentially uses web interface technology to create a local app, so you could run it on your host computer and have some kind of a configuration interface on it that sends config values back through the USB connection. So we don't necessarily need a Wi-Fi connection or a second processor to do it. What we can do is have the interface on the local PC, and it could have a list, for example, in this case, in the Open Adaptive Controller case, we've got 8 inputs, so you could have a list of the 8 inputs, and you click on one to configure it, and then you specify what event you want to happen when that input is activated. And the event could be move the cursor to the right 27 pixels, or it could be send the letter A, or it could be all sorts of things. And then send that configuration through the USB connection using just regular, serial protocol, because the device itself can come up on the computer as a serial port and as a keyboard, or as a mouse, or as a game controller. And we could use the serial interface as a back channel to send configuration values to it, and also to extract configuration values. So in your interface, you could click a button to fetch the current configuration from the device and display it on the screen. Then you could customize it and click send and have it send back to the device. That is the sort of thing that would make it a whole lot easier for end users to interact with. They could grab the device, plug it into their computer, and then tune it to do exactly what they want without ever knowing that the Arduino IDE exists. And that would be the ideal situation. We don't want people to have to recompile firmware just to change a config option on a device. I mean, that's a real DIY sort of hacker way of going about it. So thanks for the suggestions. Those are interesting, and you're all definitely thinking the same way I am. Now there was a question. There was. There was a comment from Stephen in the chat. Have you looked into the microwave sensor? Yes. I have not used one though. I've spent a lot of time Googling and watching videos and reading data sheets. There are some really, really interesting microwave sensors at the moment. Microwave sensors is one of those things that if you'd looked at it 10 years ago, it would have been ridiculously expensive and very hard to configure, and so specialist that you just don't even think about it. But there have been a few things that have brought the cost of microwave sensing technology down. I think one of the major drivers has been anti-collision systems in cars. So cars that have anti-collision typically have a radar system in the front bumper that detects the distance to the car in front. So those cars that do things like maintain a distance to the car in front do that by using radar to measure the range to whatever object is in front of it and then maintain it. And when technology gets out of the lab and it gets deployed on a consumer device, the cost of it falls dramatically. Just like what happened with accelerometers. I mean, before smartphones had accelerometers in them, an accelerometer was a super expensive piece of lab equipment and you would need to do like a specialist order for it. Now you can buy a little MEMS accelerometer on a chip for $1 or whatever. They're no longer a $10,000 device. And same for small cameras. I mean, all phones have got at least one camera in them now. Most of them have got 2. Many have got like 5 cameras in them. And you can produce a camera for a few dollars. Before they got into phones, the idea of a low-cost camera was just science fiction. So economies of scale make a big difference. And small-scale microwave-based radar systems seem to have dramatically fallen in price and improved in availability over the last few years. So yeah, and Station 240 said, yeah, using some LiDAR as well, but that's not cheap. Yes, so we have a LiDAR currently over at Chris's place. There is a LiDAR unit that was being put on a robot, but that project got put aside. Anyway, I'm going to stop chasing this particular squirrel and just answer a couple more of the general ones. So North Shore PX said, do the relays inside the Sawn-Offs rated to control the currents used in electric heaters? I'm in New Zealand, so a similar situation to Oz. Yeah, so that's a good question. The relays in a Sawn-Off, there are a couple of different types. The most common relay that IT'd use in their Sawn-Offs is a little 10 amp 240 volt relay. So in theory, it is rated to 10 amps 240 volts. But one thing I've noticed is that if you are pushing a relay to its limit, you dramatically decrease its life expectancy. If you've got a 2.4 kilowatt heater, then you are pulling 10 amps at 240 volts. You're really running right on the spec limit of the relay. And each time the relay opens and closes, there will be a little bit of an electrical arc that jumps between the contacts as they are in the process of opening and closing. And over time, that electrical arcing will hit the metal surface, and you'll get carbon buildup and other bad things will happen. So you will no longer have two nice clean clean metal surfaces contacting each other. They get dirtier and dirtier and rougher and nastier, and they will fail over time. So in Chris's case, I think he's gone through, I can't remember if it's been replaced once. I think it might have only been replaced once. So we've replaced the Sawn-Off that he uses to control the heater, because it gets turned on and off quite a few times each day, and the heater is typically set on its maximum setting, which is 2.4 kilowatts. So it's running hard on the limit of the relay. Now there are different Sawn-Off models that have different rated relays in them. There are things like the Sawn-Off TH16, which has a 16 amp nominal rated relay, so obviously there's a bit more overhead in that. But if you are controlling a device that is right on the limit of the relay rating, it's probably a good idea to use, well, I was going to suggest using an external relay, but there might be better solutions. Yeah. Well, I'm going to limit it to just saying it's not a good idea to be running relays hard on their rated limit constantly. And that is the limit for a reason. It doesn't mean that you can run 9.9 amps at 240 volts through it and it will be 100% fine. And if you run 10.1 amps through it, it's going to blow up. I mean, the limits are not that discrete, and it's really the rating limits on things like relays are really indicating you should not exceed this, because then you'll have problems. But if you're getting very close to it, you don't want to be running 100% hard on the limit all the time. Pancake Legend, hey, Pancake Legend is here in the chat, said QMK is the keyboard software, and yeah, Cable Diorama Networks is one that does high-end. Okay, for those of you that don't know, Pancake Legend is a local member of the Melbourne hackerspace who does very, very nice mechanical engineering stuff. So that's where I a couple of times I've said, if you don't measure, you don't know. That's why I have these within reach all the time. That came from Pancake Legend. So, yeah, so Pancake Legend, who is Andrew, is one of these obsessive people that builds custom keyboards, and because of his mechanical aptitude, he has designed a couple. There's one keyboard in particular that he was working on a while ago that is an absolute work of art. It's beautiful. So custom PCB and layers, and I won't go into it right now, but Andrew is the person that would know in terms of software for how to set up custom keyboards. Yeah, so some other comments. What else was there? Oh, this is interesting. So, all right, this is a squirrel that I am going to chase and not catch. The Rulesh said there is a company that sells Sawn-Offs which are certified for Australia. If you bring your own, they aren't the exact same device. Yes, exactly. I've mentioned before, Oikotech here in Melbourne is a company that imports Sawn-Offs, and they have paid to have the lab testing and certification done. So if you buy them from Oikotech, they are actually fully certified. But if you buy them directly, they're not. And following on from that, North Shore PX said, worry is about flashing. If you flash, does it break certification? Ooh, that is a fascinating question. And that is the squirrel I'm not going to catch, but I'm just going to mention a couple of things. So, I actually don't know, and I would be really, really interested to know. It's entering a grey area, and okay, I'm going to use a different example that will help illustrate the problem here. In fact, two different examples. If you most devices these days are a combination of hardware and software. When they are certified in terms of the way they behave. And if their behavior changes, they may no longer be certified. A classic example would be if you have a device with Wi-Fi built in and the radio for the Wi-Fi is under the control of the microcontroller, so that it can do things like change the output power to optimize the link, like the connection to some other Wi-Fi device like the access point, and you want to be able to ramp up the power on the transmitter in order to be able to reach a more distant access point, but you want to ramp it down in order to save battery power. It is very possible that configuration parameters controlled by software will change the operation of the Wi-Fi transmitter in a way that can make it work, like make it break regulations. So you can have a configuration that works with specific frequencies or channels and with a certain output power and get it certified, and then tweak a register in a microcontroller, and all of a sudden it's outputting more power or transmitting on different frequencies that aren't legal to do in that particular area, and all of a sudden you have overcome the whole point of the certification and you've broken it. Now, a good example of that. Okay, so this is a fun example, and I've told this story before, so I won't go into it in too much detail. When I was working on ArduSat, which is, how long ago was it? 7 years ago, 8 years ago, something like that. ArduSat had onboard GPS, and there are limitations on GPS that mean that if you are manufacturing a GPS receiver, so it's a device that uses the signal from the GPS constellation to tell you your current position and velocity and all of those sorts of things. you're not allowed to produce a device that will work in a missile, like in a cruise missile. So you are required in your firmware to shut down the receiver if you detect that you're above a certain altitude or traveling beyond a certain speed. And that is to prevent people from going out and just buying a cheap GPS receiver and building their own cruise missile. It's part of the way... anyway, I won't get into all of that. So the result is that if you take a standard off-the-shelf GPS receiver and you send it up really high and make it move really fast, it'll just stop working. And that is under the control of the firmware. Now in ArduSat, what we had to do was get special certified GPS receivers that could go into the satellite, because it needed to be at about 400 kilometers altitude, and it needed to be traveling at, what was the speed? 19,000 kilometers an hour or something. It would orbit the Earth every 92 minutes. So it was hiking. Both the altitude and the speed were way outside what a GPS is allowed to do. So what happened was that the company that supplied the GPS modules that goes into the satellites supplied two different types of GPS receiver. One is the one that is certified to go into the satellite, and one is the exact same hardware but with different firmware, and it has the limitation that it will shut down if it goes outside its operational parameters. And then what that allows you to do is use the restricted one for ground testing and do all of your development, and you put the restricted one which into the satellite, and that allows it to continue functioning even when it's very high, moving very fast. But there is a chain of custody for the restricted receivers. You have to, their location has to be known at all times, and you have to sign off for them, and then when they go into the satellite and go up into orbit, they burn up. So basically you need to certify that it's been destroyed or returned to the manufacturer. And the only difference between those two GPS receivers is a couple of bytes in the firmware, just the flag that says, am I allowed to go high and fast? So you can change a device from being legal to illegal by changing a couple of bytes in the firmware. And what I don't know is, in the specific case of a Sawn-Off, if you buy a certified Sawn-Off from Oikotech and then you flash it to put Tasmota on it, does that break the certification? Now the reality is that we know everybody does this. It's the difference between what is technically legal and what people actually do. There's a huge difference there. So, but if you were going to go all lawyery on it, I don't know, because certification is done with specific firmware loaded on it. And of course you have the whole problem of, if you make something like a, Mike O'Connor said, certification records the hardware and the software revision. Yes. So the thing is that there have to be exceptions to this, because if you think about a company that makes a smart light globe and it has firmware in it, the smart light globe has Wi-Fi, so it's a radio transceiver. It's controlled by the firmware. That light globe will be certified. It'll have to go through all of the lab testing, etc. Does that light globe need to be recertified because the manufacturer issued a firmware update? And I think if you followed the letter of the law, the answer is yes. But in terms of reality, I don't know. I would be interested to know if companies like LifeX and Philips have to go through the entire certification process every time they push out a firmware update, because that would be crazy. And it would also be a real limitation in terms of things like security fixes. If you've got a problem, like if you've got a really bad security problem with, and this actually happened to LifeX a couple of years ago. So you've got a really bad problem where your private keys are being exposed, and you want to push out a firmware update that is going to fix this security problem to millions of devices all around the world, and you've got to do it quickly. Can you afford to wait to go through the certification process before you push out that fix? Anyway, big can of worms there, and it's something that I am not qualified to answer. So Mike O'Connor, who, if anyone should know about this stuff, it should be Mike, who works on really interesting things that, if they potentially go wrong, could cause a threat to human life, said that what happens in reality is that they certify the hardware and software and only recertify if there are questions caused by a problem like a fire or human damage. Yeah. So this is where I think there is that gap between following the letter of the law and reality. And if everybody followed the letter of the law, I don't think it would be practical. The burden on manufacturers would be so high. Now, we're getting towards the end of the 2 hours, so I'm going to try to catch up on a couple more comments. There are a bunch here. So, what do we have? Oh, Station 240, so better off replacing the relay with an SSR. This is in relation to the relay output on the Sawn-Off, and whether it is rated enough to do a 2.4 kilowatt heater. So an SSR stands for solid state relay, and an SSR, the idea is that it's a device that you can drop in, and it is almost a replacement for a relay in terms of its functionality, but instead of having a coil and contacts that physically move, it's entirely solid state, hence the name SSR, solid state relay. And normally what will happen is that inside the SSR, it'll have devices like a triac in order to do the switching. And so the thing is that it can complicate things, because a relay is an extremely simple device. It's electromechanical, and what it's doing is physically taking two contacts and moving them together. It's as if you have physically flicked a switch and made these two bits of metal touch, and then it conducts or it doesn't conduct. And apart from variations in the characteristics like AC versus DC and the difference in arcing, once it's closed, it's effectively just like a piece of wire. It doesn't really have any characteristics, ideally, if the contacts are clean, etc. So you can run whatever signal you want through it. With a with an SSR, there are a few different types of solid-state relays, and they have different characteristics depending on the type of thing that you want to switch. So if you're switching, like the big difference is AC versus DC, and there are other characteristics. So you need to match the type of SSR to what you're switching. Like with a relay, you can switch different things and it doesn't care. With an SSR, you need to be a little bit more careful. Roman asked, how short can you go with the stem part of the zero deflection joystick while still being able to fit the sensors? Thinking whether micro zero deflection joysticks are feasible. You can go shorter, and we've done some experiments with that. So, and of course, one thing that a few people point out is the little joystick nubs that are in some laptops. I think, who is it that does someone's famous for doing it, I can't remember. HP or someone used to do laptops, and probably still does, with a tiny little nub. It's like a pencil eraser in the middle of the keyboard, and you can push it and move the cursor around. That is, I haven't actually looked at how those work, but I assume it's doing it in a similar way, just with a lot less sensitivity. So this is a custom machined two-dimensional load cell, and you can see that it's got one set of holes through there, and then you turn it this way and it's got another set of holes through there, so we can measure the different axes. And part of the reason for doing this was we wanted to be able to shrink it and make the whole thing shorter. But for now, I'm losing things. For now, we don't actually care that much. In terms of mounting this on a wheelchair, this is easily short enough to fit within the space that we have available. The wheelchair frame has a tube that comes down, it loops down and comes back up, and it's there specifically as a mounting location for different interface devices. So with an arm sitting in a, gotta get the angle right, sitting on an armrest like this, and the hand falling in a natural position, there is plenty of room to mount the joystick down here and bring it into the correct location to be controlled. And that height is not a problem because there's plenty of space in the frame. But yes, we have actually done a few things. It's a little bit hard to see, but the end of one load cell here, you can see this load cell is actually going inside the other load cell. So this one has been machined with a slot, and it's a little bit hard to see on a camera, but there you can see the bolts that go through. This has been machined to have it looks like a Y shape, and then the top load cell slides down into it, and it's cross drilled so that the bolts go through. And part of the reason for that was to make it mechanically very rigid, but also it reduces the length by merging the two load cells together. But there are plenty more things we could do if we wanted to make this shorter. This connection gap could be reduced. We could take a bit off the bottom of the bottom load cell here. We could take some off the top of this one. We could take 20 millimeters off the length of that without any trouble at all. Like, barely an inconvenience. But we haven't needed to. So it's one of those things where you optimize where you need to optimize where the real problems are. If you were trying to make something that worked on a desk, something I should point out is this thing. So I showed this last week as well. This is the 3D Connection Space Mouse, which I use with Fusion 360. And this essentially works the same way. I haven't taken this apart because it's very expensive and I want it to keep working. But internally, I'm pretty sure that what this is a very complex structure of load cells, so that, well, or a load cell with many strain gauges on different dimensions, so that it can detect rotation, sliding in both axes, rolling in each axis, lift and push. So this is a I think it's a 6-axis input. 1, 2, 3, 6 axes in a single device. So you just grab this and then you got 6-axis control. At the moment we're only doing 2-axis control. We're not detecting things like twisting or press and pull, which are other things that could be detected. All right. Okay. Now, let's have a look. What else? All right. Oh, Raspberry said, wanted to thank you for the video about the Sawn-Off Zigbee to use it as a router and extender, help with low signals in the far reaches of my property. Cool. You're welcome. There are going to be more Zigbee videos coming up. I've still got that Zigbee to Tas motor video and the device sitting up here that I want to cover. There was a question. Just doing a quick scan to the end before I get back to a question I saw. Okay. In terms of the contacts, like a relay versus an SSR. So Mike had a couple more very good bits of input. So I've been working on a machine which has two 6 kilowatt heaters, one for air and one for water, and we use a single 3-phase SSR. We drive this with PWM. That's, yeah, switching some big loads. And he also says if the switching is less than about 4 to 8 times an hour, I would use an industrial contactor. Yeah, so that's another way of doing it. I won't get into this in a whole lot of detail now, but if you start looking into high power switching, then the term contactor is something that you'll come across, and a contactor is different to a relay in terms of the way mechanically that it works. So that's a discussion for another time, but yeah, that's a good point. If this is a real problem that you're looking at right now, you want to be able to switch higher loads and you don't know what to look for industrial contactors, and you might get some clues from that. A bit of a quick Google search. Okay, so I think the last thing I will wrap up with is getting back to a question a little while ago, which was a throwback to ArduSat. So, Family Plan said, why was there never an ArduSat 2345? And Scott replied, politics, which is kind of correct. I'm going to grab a couple of things just from up here because they are cool. I like showing them off. I've got lots of dusty hardware here. So someday I want to set these up in like a little display case because I think that would be really cool. This is one of the early prototypes for the ArduSat Payload processor module. So it's just in a little laser cut enclosure here to protect it. And you can see a couple of patch wires on there because I screwed up the design. So this is the board that went into the satellite and ran all the experiments. Excuse me a second. And yeah, so that was the first version. It was fabricated, had a couple of problems that we discovered in bench testing, got revised, and that is the version that matches. Which one is this? Yes, this is the actual flight ready hardware for the payload. There's a version number on it somewhere, but there were 5 of this specific board. There were 5 manufactured. I've got 1 of them. 2 of them went into space, and 2 were used in excuse me. 2 of them were in the ground test systems. So what happens is that there are multiple copies of the hardware that are assembled and then go through what's called the integration process. Integration is when you go into a clean room and all of the different parts of the satellite are put together, and it's all tested, and you make sure that it's flight ready and it's kept in a sealed container, etc., so that it stays clean prior to launch. And so there were 2 satellites, ArduSat X and ArduSat 1, that were the full, that actually went into space. And then there were 2 others that were assembled but didn't go into space, and they were used for things like software testing prior to pushing new firmware updates to the units that were in orbit. Because if you brick a satellite, it's not so easy to fix. So what would happen is that when new software updates needed to be run, they would be tested on the ground-based devices, where you can still get to ICSP headers and reflash them if you absolutely have to. And then once the software update had been tested on that, it would then be pushed up to the satellites that were in orbit. So I actually don't know where the other two ended up, the two ground units. They are probably still in the possession of what used to be called ArduSat. The company is now called Spire, and they changed their business plan rather dramatically. But this is the only one I currently know the whereabouts of. So that is the actual equivalent hardware that went into space. And since then, I made a couple more just for my own amusement. This is a slightly changed version of the same thing. So it's equivalent hardware, and it's on a little ground test breakout. So this PCB that it's sitting on just provides breakouts for communications and power and different things. So what you can do, and there's normally a big socket in there. So this is designed to go into a vacuum chamber, and it's part of the testing and certification process. So there's a connector on here which is a DB whatever it is 25 connector, and they are available in space rated version, and you can also get a cable gland. So what happens is that there is a wiring loom that goes through the wall of the vacuum chamber, and it plugs into the device that's inside the chamber. So when you're doing testing of satellite hardware and other devices that are going into space, then what you do is set up the satellite within the vacuum chamber and plug in a test harness. Now the standard way of doing that is that you have a DB20, well there are a number of different options, but in this particular case it was a DB25 cable, so it passes through the wall of the vacuum chamber, plugs into your test rig, and on the outside there is a breakout that exactly matches the same connections. So what you can imagine is this goes inside the vacuum chamber. There would be, in the proper version that's used, there would be a socket populated on the PCB, and the wiring harness just plugs into it. And the idea is that whatever device you are testing in the vacuum chamber, you need to make a breakout carrier of some kind that fits that standard DB25 connector. So you could have a whole lot of different types of hardware that you're testing, and they all plug into the same breakout. And then on the other end of it, you have your test gear outside the vacuum chamber, so you can power up your device and you can run it, do whatever you need to do, make sure that it's working properly. So this is the what's actually sitting on this board is equivalent to the flight ready hardware, but it's sitting on the ground test breakout to go into the vacuum chamber for thermal testing and all of those other fun things. And this one never flew in space, but this was just a little experiment that I did making a power supply module for a CubeSat. So this is a board that has there's a battery that goes on there, and it has inputs from the solar cells and external charge input and a few other things. But this was like a ground equivalent to a space-based power supply system. Alright, what happened was ArduSat started as an educational satellite. The whole idea was that school students should be able to invent their own experiments and push their code up to the satellite, run the experiment, and get the results back using the sensors that are built into it. And that's what the first two did, ArduSat X and ArduSat 1. But what happened was that after that, the company pivoted into commercial space-based ground observation, and it was renamed from ArduSat to Spire, and the education business was outsourced to another company that took over the process of creating all of the educational content around the ArduSat brand and then making that available for schools and things. So it largely dried up. I haven't even looked at it for a while, so I don't know what state ArduSat is currently in, if it's even still running. Spire is still running, so Spire is the rebranded company that was originally ArduSat, and it's providing services like observation of ship locations using satellites, being able to track things on the ground from space. But I haven't had anything to do with it for many, many years now, not since the original ArduSat X and ArduSat 1. It all went off in a totally different direction. I was really excited about the idea of providing hardware like this to schools so that just as a representative size, like if you imagine a few of these boards stacked together, different modules, you'd have a power supply board, you'd have a flight controller, you'd have the payload board, you'd have a communications board, a couple of others, all the major functional blocks of a satellite you could have stacked up as a little CubeSat, and you could make that available to schools as an educational device for a very low price. That's really what I was wanting to happen, but ArduSat ended up going off on a different direction and rebranding and getting into commercial tracking of ships, and the education side of it sort of went away. It was no longer the focus of the people that originally started the business, so it didn't get the same love that I thought it deserved. So, Andy pointed out, I made a comment earlier about the LifeX security issue. I misrepresented that. So Andy said that the LifeX security issue wasn't LifeX's private key compromised, which is what I said. It's rather under very specific circumstances there was a small window during onboarding. Yeah, okay. So it wasn't a situation where all of a sudden all LifeX globes were insecure. Don't think that. That's not what I meant. I was probably overreaching there when I was trying to think of an example where certification could get in the way of a critical security update, and as a company you want to keep security patches and updates deployed as frequently as possible or with as little latency as possible. So if you discover a problem, you want to get that problem fixed and out onto all the devices as quickly as possible. You don't want to have to leave everything vulnerable for weeks or months while you go through a certification process before you can push that update. So sorry for misrepresenting the problem with LifeX. It wasn't as bad as I made out. But that's the sort of situation that is potentially a big issue. So I ended up chasing squirrels into space today. I'm going to stop now. Thank you very much for coming along. Oh, one final thing. Here in Melbourne, we've gone into, as I said last week, we're back in sort of a lockdown, and so we're at what's currently being called a stage 3 lockdown. So you're not meant to leave the house unless it's for like essential reasons. And there's a potential that we might be going into stage 4 lockdown soon, which is do not leave your house under any circumstances, pretty much. And I don't know if that's going to happen or not. But next Sunday is my 50th birthday. And it's so the day of the live stream is my actual birthday. And because the reason I brought up the lockdown is that because the lockdown is happening, I'm not going to be having anything for my birthday, certainly not now. And I will probably be here with you, but maybe I'll do like a I don't know, I'll eat a birthday cake in front of you or something. Maybe. We shall see. But I won't be going out and partying or whatever. Not that I would do that anyway. It's not my nature. But I will be here next Sunday live streaming, and I will see you all then. So thank you very much for coming along, and I hope you all have a fantastic weekend, and go and make something awesome. So thank you very much. See ya.